Okay, here's an indication how to do part A for this problem using both Cartesian vectors and geometric vectors. So this page 1, is with Cartesian vectors. So here's the first vector. It's the boat, which is 30 knots south, 70 degrees west, which means this angle right here is 200. So because this is a 20, and so we're 20 degrees past 180. And so the x and y components of the red vector are 30 cosine 200, 30 sine 200. For the wind, we're going in the direction south, 60 degrees east, which means this angle is 60 degrees past 270 or 330. So the components, x and y components of the green vector are 7 cosine 330, 7 sine 330. And to get the components of the resultant vector, we just add the x components and add the y components. So we say the x component of the resultant vector is this expression right here, where we're in degrees. So that means this distance right here is negative 22.12, and this distance is negative 13. And if we want to find out what the magnitude of that resultant vector is, and by the way, that result, whoops, I did that wrong. The resultant vector looks like this. Not quite as long as 30 knots, it's 22 and 13. So there's the resultant vector. Sorry, I did that wrong. Erase this. So the x and y components of the resultant vector are negative 22 and negative 13. And if we want to find the magnitude of the resultant vector, we use this formula right here, which is like the distance formula or the Pythagorean theorem. And then this angle theta right here is the inverse tangent of y over r. But if we use a calculator to calculate this angle, it'll give us an angle in the first quadrant. And we have to add 180 to that to get around to here. So there are the components of the resultant vector. You could convert to a bearing if you wanted to. We know that theta 1 is 211. We could subtract that from 270 and get that it's south 50 some degrees west. Okay, but that's what we're going to focus on when we go to the second board, those two values right there. So let's go to board 2. This green triangle represents, well, this is the vector for the boat. This is the vector for the wind, but it's been transposed down here as an end-to-end. And this is the resultant vector right here. And if we want to find r sub 2 given this, it looks like if we put a 30 here and a 7 here, we could be using the law of cosines if we knew this angle right here. And here's the key. If we picture that wind vector up here, we know that this angle was 30 because this was a 60. If we extend this line this way, vertical angles are equal, so that's 30. We already know this is 20 because the boat was south 70 degrees west. And by parallel lines cut by a transversal, alternate interior angles are congruent. So that angle here has to equal 30 plus 20 or 50. And so here we are using the law of cosines to find r sub 2. It matches exactly what we got using Cartesian vectors. if I take the inverse sine using the law of sines, I can find this angle right here, whatever inverse sine of 7 sine of 50 over r sub 2 is. But then I have to add 200 to that because this is 200 plus what I found there gives us the theta for the resultant vector. And that also matches what we had on board 1. Okay, there you go. Hope that helped. If you have any questions, post a comment.